Inside the jackfruit is a natural latex compound. This sticky sap protects the fruit from insects and oxygen.
Unlike potatoes, jackfruit contains irregular starch networks and residual sugars. As moisture flashes,
instead of one constant temperature, the fryer is zoned. Higher heat at entry drives moisture out quickly. Lower
particle size matters. Too coarse and seasoning falls off, too fine and it dissolves unevenly. Manufacturer engineer blends to match the chip's surface roughness.
Jackfruit is not just another tropical fruit. It is the largest tree-borne fruit on Earth, capable of weighing over 40 kilograms.
Timing is everything. Harvest too early, and the starches are unstable. Too late, and sugars.
Once harvested, enzymatic reactions begin immediately. Heat buildup during transport can convert starches into.
By the time the fruit reaches the factory, its biological clock is already ticking. What happens next will determine stores. Quality control doesn't start on the production line. It starts at intake. Each batch is logged, traced, and graded. Only after latex control, microbial reduction, and moisture stabilization is complete can mechanical processing begin.
Residual surface moisture can spread latex during cutting and dilute natural starch concentrations. Air knives use controlled high.
This wash is not cosmetic. It removes soil bacteria, fungal spores, and surface sugars that could ferment later. From the machine's perspective, every fruit must behave the same. Variations in size, density, and shape are correct.
In chip manufacturing, cutting is not about shape, it is about physics. Slice thickness determines how heat.
Blanching deactivates enzymes responsible for browning. It partially gelatinizes surface starches, helping slices fry evenly and maintain a lighter color.
Jackfruit seeds and core fibers contain different starch and protein ratios. If left in, they would cook unevenly.
In low-oil chips, a micromist of neutral oil may be added. This improves.
Holding time between pre-treatment and frying is tightly controlled. Even minutes of delay can. Some producers skip blanching entirely. By controlling oil temperature and fryer dwell time instead, they preserve. Gravity is used whenever possible. It reduces mechanical stress, prevents edge damage, and keeps slice surfaces intact.
Any surface water left behind becomes steam in the fryer. That steam can rupture slices and increase oil up.
Before heat is applied, machines visually inspect each slice. Thickness outliers are rejected now, because once frying begins, defects become permanent. High-speed vision systems detect discoloration, blistering, or uneven shape, flaws invisible to the human eye at production speeds.
At this point, the chemistry is locked in. What happens next, inside the fryer, will
Before frying, manufacturers must make a critical decision, pre-treating the slices or sending them directly to oil. Frying is not just cooking, it is a controlled exchange of heat, moisture, and oil. For jackfruit chips, this exchange.
unlike potatoes, jackfruit contains irregular starch networks and residual sugars. As moisture flashes,
instead of one constant temperature, the fryer is zoned. Higher heat at entry drives moisture out quickly. Lower.
From inside the fryer, time moves in seconds. Each slice remains submerged just long enough to lock in structure to lightly, not a moment longer.
Seasoning is not added randomly. It is engineered. Flavor must bond to the chip's surface before residual heat disappears. As chips cool, surface pores close. Applying seasoning while the structure is still thermally active allows. As slices leave the oil, surface starches rapidly set. This brief moment determines whether the chip feels light and crisp or heavy and greasy.
The drum's rotation angle and speed ensure even coating. Too aggressive and chips break. Too gentle.
Rejected chips are removed instantly. At this scale, even small defect rates translate into tons of product, making early rejection essential.
Cooling stabilizes structure. Without it, trapped heat would continue cooking internally, collapsing the crisp shell formed during frying.
Once flavor bonds to the surface, it becomes part of the structure itself. From here, the chip's taste profile is locked in.
Only after passing physical, chemical, and visual tests does a chip earn the right to be sealed and shipped.
Moisture content determines shelf life.
Even fractions of a percent can mean the difference between months of crispness and rapid staling.
Particle size matters. Too coarse and seasoning falls off, too fine and it dissolves unevenly. Manufacturer engineer blends to match the chip's surface roughness.
Oxygen accelerates oil oxidation, leading to rancidity. Nitrogen flushing displaces oxygen, slowing chemical degradation and preserving flavor.
A perfect chip means nothing if the seal fails. Bags are randomly tested to ensure seals withstand handling.
Packaging is not just branding. It is the final preservation system. Once sealed, the chip must survive
Automation ensures uniform stacking, reducing crush damage and improving warehouse efficiency.
What began as a tropical fruit now travels the world fabric, connecting local farmers to global consumers. This is how giant jackfruits become something small, precise, shelf-stable, and ready to travel the world.